Hi, I'm Mariah Harris. I've been taking this class virtually this semester, and this is my final project. This is the WriteRight, which is a wearable device for handwriting correction that uses Vibro-tactile feedback. The motivation for this device is there are proven benefits to having visual cues along with haptic cues for handwriting development and retention. Some people that might use this device are kids who are learning how to write or people who just can't write with their non-dominant hand anymore. This device provides feedback when the user is writing outside of the lines. So for example, I'm writing the letter T and I'm a little bit too far to this side, to the left, and I start feeling some feedback on the left side of my arm. And similarly to the right side, feel vibrations here on the right side. And then when I'm writing like the bar of the T, then I'll start feeling feedback up here and then down here, signaling that I need to move back towards the actual letter. This is a closer look at the inside of the sleeve, and I made this for my left hand since that's my non-dominant hand. And you can see that there are 3 motors in each quadrant. For the left and right motors, I used just a cluster of 3 motors since that's what felt best. And then for the up and down motors, I placed them in a line so that I could experiment with some different feedback algorithms. And then I soldered some jumper wires to all of these motors. Here's the output. And it connects to this electronics box, so let's take a look at that. I use an Arduino Nano 33BLE and then a PWM module with 16 channels. So I'm just using 12 of them. And then I have 6 H bridges here. Each one is driving 2 motors. I chose to test this out by creating a handwriting interface on my computer. I don't have a touchscreen, so I'm just using my trackpad and a stylus. But I wrote this Python program that runs in the background, and it sends my cursor location to the Arduino via Bluetooth. The Arduino then processes the data and it determines what the positional error is between my handwriting or the cursor and the model letter, which is this over here on the right. And if I'm off track, the Arduino commands the vibration motors to buzz my arm and send me in the right direction. Okay, so this is it in action. So the Arduino code is uploaded and it's in standby mode waiting for Bluetooth cursor data. And then once I start the Python script, all right, so then the Arduino starts receiving data and then I can start writing the letter T. So let me make my way over here to the start position. So it found the start zone and then I started writing down the stem. And then you can see, okay, I'm starting to get a little bit of error here. And then as I increase over here, you can see the outputs of the motors, the percentage that they're set to. So you can see if I'm like right on the letter, 0%. And then if I start going to the left, it's telling me, oh, gotta move to the right, get back to the letter. I put these outputs here so that, you know, you can see what's actually happening without being able to feel it, obviously, through the video. So anyway, make my way down, finish the letter. All right, the stem of the letter T is complete. Then find start zone of the bar of T. And then same thing here. A little bit of error there. And then I finish the letter. I tested out 3 different algorithms for feedback just to get a feel for what type of vibro-tactile feedback feels the best. This made the biggest difference with the up and down motors, which are in a line on the arm. So what you just saw was the group sync algorithm where the vibration intensity is equal for all of the motors. And then this next one is my consecutive algorithm, which increases the vibration intensity one at a time. So once motor 1 reaches 100%, then motor 2 joins in, and then motor 3. The third algorithm is called consecutive offset. It's similar, but motor 2 can join in before motor 1 reaches 100%. This one's my favorite because it simulates the smoothest transition and you can feel the direction that you're supposed to go in from the vibration intensity, and then the location of the motors that are being triggered. All right, so we'll finish that up. Okay, so that was the WriteRight for my haptics project. Thank you.